Welcome, geometry students, to Chapter 2, Section 4, Biconditional Statements and Definitions. These are very cool. Pause, come back, and check your answers to this warm-up. Number 1, your conditional statement would be an if-then statement, right? If two lines intersect, then they intersect at a what? A point, right? Number 2, if a number is odd, then the number is one more than a multiple of 2. And converse, we switch the conditional statement from if P then Q to if Q then P, right? So if Pedro lives in Illinois, then Pedro lives in Chicago. If Pedro lives in Illinois, then he lives in Chicago. Is that true? Do all people who live in Illinois live in Chicago? No. So that's a false statement. All right? Okay, so when you combine a conditional statement and its converse, you get a biconditional statement. So a biconditional statement, as you can see, is a statement that can be written P if and only if Q, which means if P then Q and circle that, if Q then P. Q, huge, huge. The conditional and the converse are both part of our biconditional statement. Very cool. One way to write that would be using a double-headed arrow, like it goes either way. If P then Q, if Q then P. Okay, that's what that means. So again, I'm just clearly stating that again. If P then Q, then Q then P. There are 3 ways to write this. You could write P if and only if Q. You can also write it P if and only if. So a double F on your if, okay, Q. Or you can use the arrow notation as we saw up above. If P then Q, if Q then P. If P, if and only if, P if and only if Q. Very good. So let's write the conditional statement and the converse for this and create a biconditional. So an angle is obtuse. Oh no, this is a given biconditional, isn't it? If an angle is obtuse, an angle is obtuse if and only if its measure is greater than 90 degrees and less than 180 degrees. So if we start by using the beginning of this biconditional, an angle is obtuse. If an angle is obtuse as our hypothesis, we could then say its measure is greater than 90 degrees and less than 180 is the conclusion, right? There it is, hypothesis, conclusion. All right? So if we say that, and this is biconditional, if and only if, then we should be able to say if Q then P as well, right? So we can say the 2 parts of the biconditional, I guess we've already said it. We really want to say if an angle is obtuse, then its measure is greater than 90 degrees and less than 180, right? So this is what you need to have down. We also want to say the converse. If an angle's measure is greater than 90 and less than 180, then it is obtuse. So make sure you pause and have that down for this biconditional. All right, let's try it again. We're going to write the conditional statement and the converse within this biconditional. A solution is neutral if and only if its pH is 7. So pause the video, write the conditional, the conditional and the converse. The conditional would be if a solution is neutral, then its pH is 7, right? And the converse would be if the solution's pH is 7, then the solution is neutral, or it is neutral. This time for the conditional statement, we are going to write the converse and a biconditional statement. So pause the video and start by writing the converse of this conditional, and then write the biconditional statement you can make given the conditional and its converse. All right, so the conditional says if points lie on the same line, then they are collinear. So the converse would be if points are collinear, then they lie on the same line. And then the biconditional we can state, given this scenario, is if actually we don't start with if, do we? We say points lie on the same line if and only if they are collinear. Awesome. All right, so let's talk about the truth value of a biconditional statement. This is kind of interesting. To be true, a biconditional, to be true, both, I'm sure you are guessing here, or you logically are thinking that both the conditional and its converse must be true. So for a biconditional to be true, both the conditional and the converse must be true. Okay, so we're going to determine if the biconditional is true. If false, give a counterexample. A rectangle has side lengths of 12 centimeters and 25 centimeters if and only if its area is 300 centimeters squared. So the conditional here would be if a rectangle has side lengths of 12 and 25 centimeters, then its area is 300, right? And so the conditional is true. 12 times 25 is 300, so the conditional is true. Looking at the conditional now, we can make the converse, right? If a rectangle has an area of 300 centimeters squared, then it has side lengths of 12 and 25 centimeters, right? So, is that true? If a rectangle's area is 300, are the side lengths always 12 and 25? No. You could have side lengths of, let's say, 10 and 30, right? You would still have the area of 300, so this converse is false. The conditional is true, the converse is false, so the biconditional is false, right? Both would be true in order for the biconditional to be true. Okay, let's determine if this biconditional is true. If false, give a counterexample. A natural number n is odd if and only if n squared is odd. A natural number, in our series we're more used to using counting number or whole number. Natural number, there's debates in the definition of natural number. Actually, if you look that up, it's either counting numbers 1, 2, 3, and so on, which are the positive integers, right? Only, or some mathematicians also include 0. So let's just say it's the set of whole numbers, natural numbers. So is this true? Let's see, let's build the conditional statement, right? If a number is natural, or I'm sorry, if a natural number is odd, then n squared is odd, right? Well, can you think of a natural number that is odd? Let's see, how about 1, right? 1 squared, is that odd? Yeah. How about the next natural number that's odd? 3. 3 squared is 9. Is that odd? Yeah. How about the next natural odd number? 5. 5 squared, is that odd? Yeah. Okay, so the conditional is true. And let's write the converse. If a natural number n squared is odd, then n is odd. If the square n squared of a natural number is odd, then n is odd. Let's think. So we have, like, let's say we have 81. Then would that perfect square 81, would its square root 9 be odd? Yeah, it seems like it is. What other? Let's say 49, right? 49. So 49, the base of that is 7, which is also odd, right? So it looks like the converse is also true. Okay, so in that case, they're both true. So the biconditional is true in this case. Okay? Okay, determine if this biconditional is true. If false, give a counterexample. An angle is a right angle if and only if its measure is 90 degrees. So what is the conditional? If an angle is right, then its measure is 90 degrees. The converse would be, if an angle's measure is 90 degrees, then it is right. So, it seems like the conditional is true, and the converse is true. So what can we say? This biconditional is true. Good. Here's another one for you. What does this say? Y equals -5 if and only if y squared equals 25. So let's see. The conditional would be if y equals -5, then y squared equals 25, right? Is that true? Yeah, I think that's true. -5 times -5 is 25, okay? So how about the converse? If y squared equals 25, then y equals -5, right? The converse is false. Give me the counter. The counter is y equals 5, right? So this biconditional is false. So in geometry, biconditional statements are used to write definitions. When I think of biconditional statements, I think of definitions. They are statements that describe a mathematical object, and they really can be written as a true biconditional. So in a glossary, a polygon is a closed plane figure formed by 3 or more line segments. So here we have a diagram of polygons, closed figures, see that? Formed by 3 or more line segments, and not non-polygons. Okay, open or not entirely closed, right? This is not a line segment, and so on. Okay? So a triangle is defined as a 3-sided polygon, and a quadrilateral is a 4-sided polygon. Right? So we could say if a polygon has 3 sides, then it is a triangle. We can also say if it is a triangle, then it is a polygon with 3 sides. So you see it's a biconditional. Think of definitions as being reversible. Postulates, however, are not necessarily true when reversed. So let's write these definitions as a biconditional, just like I did with the triangle. Go ahead and pause the video and try it. A pentagon let's say a figure is a pentagon if and only if it is a 5-sided polygon. An angle is a right angle if and only if it measures 90 degrees, right? Good job. All right, so now you can try the lesson quiz, come back and check your answer, and away you'll go into your assignment. There will be a quiz at your next regular class. Okay? So number 1, the converse would be if an angle's measure is 90 degrees, then it is a right angle. And the biconditional, an angle is right if and only if its measure is 90 degrees. Okay? Determine the biconditional for number 2. And we can say that this is false. A possible counter would be 30 and 40 degrees. Okay? And finally, write the definition here. Is a biconditional, so we can say a triangle is acute if and only if it has 3 acute angles. Very good. And quiz next class, I should say, right?